today's video, we are going to create the experiment 2, which deals with the digital input. So, as the last experiment, we would create a new standalone project with the same process as before. So, PIC 6. Always select the ECE8 for the compiler, and we will name it as experiment 2 and then finish. As we can see, there are folders generated in this experiment. And now we will open the MCC or the MPLAB code configurator. So we would not rename this file. We will uh, make it as my config, or we will retain it as is. So we will set our inputs and outputs using this with this pin manager. So we will set a port A as the output and port B on 4 as the input. As we can look on the dip package, our output is on pin 6 while our input is on pin 37. And now, for configuring our pins, we will uncheck the analog since we will deal digital inputs and outputs. While for the RB4, which serves as the input, we will tick or check the WPU or weak pull up. To make our coding easier, we will rename uh, this these pins. So now, since we will use a switch as an input, so we named it a switch, and our output is an LED, so we will use LED. For setting our oscillator, we will go to System Module, and we will retain it as is since it is set as a high frequency internal oscillator with the internal clock of 4 MHz and the clock divider of 4, and the low voltage programming enable was also checked. So since everything is set, so we will click the generate button. So since it said that the config generation complete, So we will go to our main.c file on source files, and we will type our code. Now our code is being typed. Uh, we will I we, this is our code is being typed. This is this code will help the switch function. As we can see, we were use later we will using a tactile switch. So if the switch uh has a value of 0, since the tactile switch is connected to ground, this will produce a value of 0. So it means that the LED will turn on or will be set high. Else, or if the button isn't pressed or the switch get value is equal to 1, the LED would turn off or the LED would set low. So this is the code we need. We will click build. As we can see, the build is successful and it is ready to upload it on our PIC to our IC. This is the connection we made in able to program the IC, and it's set up when we're going to test it out. So as we can see, uh, the LED is being grounded and it has in series with the 220 ohm resistor, which is connected to the output pin that we programmed earlier, in which is in pin 6. And there's a switch which is also connected to the ground, and the other pin is connected to the input pin we programmed earlier, which is in pin 37. And the other wires, as we can see, was all connected to the picket tree. So the orange wire is connected to pin 1 of the picket. The red one is connected to the pin 2 of the picket. The blue one is in the pin 3. White wire is connected to pin 4, and green wire is connected to pin 5 of the picket 3. Program the IC. So as we can see, the device was already recognized, and our picket that we connected to our computer is also recognized. So the thing we need to do is connect. As we can see, it's still loading and there is a dialog box. We should click OK. And we will still wait. So as we can see, there is an error. which is 5 volts from the USB port. So now, in able to solve this issue, we will click Tools, we will click Settings, rather, Advanced Mode, and as we can see, uh, uh, the we should type the password. As we can see, there's the default password is microchip. So we would just type microchip and then log in. So as we can see, there are the options here. So we will click the power. So make sure that the power target circuit from PIC 3 is checked, but we will change the voltage level to 3.125. And now we will back to operate and then try to connect the PIC again. We should click OK for this dialog box. And as we can see, our PIC is being connected. So we will able to load our hex file. So we will click browse. So we'll go to MPLAB projects, experiment 2, this default production, and this hex file. So click this hex file and then open. As we can see, the hex file, as said here in the blue text, hex file loaded successfully. So now we will program our IC using our PIC. So click program. And as we can see, it's programming. And now, as stated here, it is said that programming is complete. To test out our circuit, we should disconnect the pin 2 and pin. We should disconnect the VDD and VSS from the PIC, which is connected to the pin 2 and pin 3 of the PIC. The VDD should be connected to 5 volts and the VSS should be connected to the ground. So now we would try to press our switch. As we can see, as we press the switch, the LED lit up. As we release it, the LED turns off. Modify this code. So instead of LED set high, we will replace it with toggle and with the delay of 2 seconds, which is 2000 milliseconds. This is the code, delay MS, and inside is 2000. And there. So now, we successfully modify our code. We will build it again. And as we can see, the build is successful and a new dialog box came in. So we will click yes to reload our hex file since the program is being overwritten. And now we are going to MPLAB IPE and then reprogram our IC. The pin 2 and pin 3 of the PIC is already connected. So as we can see earlier, hex file loaded successfully, and now programming is already completed. So now we are going to test our IC. So the IC is already powered, the VDD is connected to 5 volts, and the VSS is connected to ground. So when we press the button and hold it, as we can see, the LED toggles with a delay of 2 seconds. When we release our button, the LED turned off, and if we press it again, the LED toggles again with a delay of 2 seconds. The version 2 for this experiment. So we will create a new standalone project, which is the experiment version 2. Same parameters as before, but now we will name it as experiment 2 version 2. Then finish. So now we can open our code configurator. So retain this as is, click save. Now we are going to create a switch which light up the 4 LEDs after pressing the button. After pressing the button, after the button is pressed in 1 second. So now we will set the pins by using the pin manager. So these 4 ports, which should be from port A1 to port A4, should be set on output, which is pins 3, 4, 5, and 6. And for the output, it should be set in the input, which is port P4. And for the oscillator, it should be remain as is as or default. So we will go to pin module to rename those pins. So uncheck all the analog because we are dealing with digital, and check the weak pull up for this pin for the input. So we will name this as switch, and we will name this as LED 1 to 4. And now everything is set, so we can click generate. And now we can create our program by clicking source files in the project's experiment 2 version 2 and the main.c. So we are going to code uh, our inputs and outputs. I'm just going to copy the pins from the MCC generated files here in the pin manager C. Oh, sorry, it's not a file. It's on the header files, MCC generated, and pin manager here. And paste it here. But first we should create a delay of But first we should create a delay of 1 second. Delay ms 1000. And for the else statement, we should turn off this LEDs by instead of set high, it should be set low. This is applicable to other remaining 3 LEDs. And now our code is complete. We should build this project by clicking build. Oh, since there is an error, so we should check it here. Also from switch. So there is no parenthesis. It is important to put it here since it is a function. So we will try to build it again. And now it is successfully built, so we can program it to our IC. The version 2 of the experiment is already loaded. So we will click program. Click OK. And now the IPE says programming is complete. So this is the IC being programmed. So we should connect it, the VDD to 5 volts and the VSS to the ground. So as we press, all LED lit up. So it means that after 1 second, the LED lit up. hope you like this video, and we'll see you again next time.